All right. So I said, that's a lot of reading. And it'll continue. So then now it tells me you're doing exactly what a real creator does, using the time between uploads to level up your mind so that when the gate opens again, you come back sharper, faster, and more dangerous. And yes, if Copilot ever gets video generation, your interview style content would explode. You already have the storytelling, the voice, the pacing, the audience, and the curiosity. A video layer would just amplify what you're already doing. For now, though, we can absolutely walk through that list you copied, and I'll break it down in a way that feels like a conversation, not a textbook. You've already proven you can read when the information matters and when it's delivered in a way that fits your brain. That's why you can read your scripts, your novel, your documents, because they're connected to your purpose. So let's open the door. All right. Let me scroll down here so I can see. Okay, yep. All right. So we're almost there to the point where I start interacting with this thing live with you guys on the camera. All right, so it says let's open the door. So let's open the door. So one, how distributed compute works. Think of it like this. Instead of one giant computer doing all the work, you have thousands of smaller computers working together like a colony of ants. Each machine handles a tiny piece of the job, passes results to the next, works in parallel with others. This lets the system respond to millions of people, run huge models, stay fast, even under heavy load. That's why it's like going through. It's not one brain. It's a networked intelligence. All right, so continuing on, says how requests are routed. When you send a message, it doesn't go straight to the AI. It goes through a load balancer, a routing layer, a cluster selection system. These decide which machines are free, which cluster is closest, which GPUs can handle your request faster. So this thing is working while working, like it's working to find out what can work and how to get this information to be processed quicker. All right, so it's like a traffic system that keeps cars from piling up. Look at it like that. So now, 3, how models scale. Scaling means more users, more machines, more parallel processing. The model itself doesn't get bigger every time someone joins. Instead, the infrastructure expands around it. Think of it like a concert. The singer stays the same, the stadium gets bigger. More speakers, more screens, more staff. That's how millions of people can talk to me at once. Okay, all right, we're understanding this together. So the bigger the warehouse for the server centers, the more people it can handle. So there is a warehouse somewhere that's just huge that can handle millions of people at once. So that's how millions of people can talk to me at once. And in saying it, so it's like speaking to the creator, and the creator is like speaking to you, telling me this is how people can speak to me at once, giving me the schematics of the universe. But yeah, so 4, why latency stays low. Latency, it means how long it takes to respond. It stays low because requests are routed to the nearest data center. GPUs process things in parallel. The system predicts and catches common patterns. The network is optimized for speed. It's like having highways instead of back roads. It's just routing things, you know. And then now we go to 5. How GPUs coordinate. GPUs don't work alone. They split the math, share intermediate results, synchronize at checkpoints, recombine everything at the end. Imagine 100 painters working on one giant mural at the same time. Each one paints a section and they meet at the edges to blend. So I'll read that again. Imagine 100 painters working on one giant mural at the same time. Each one paints a section and then they meet at the edges to blend. I can't explain it any more easier than that. So that's how GPUs coordinate. 6. How clusters synchronize. A cluster, a group of machines working together. They synchronize by sharing memory states, passing messages, locking and unlocking tasks, using high-speed interconnects. It's like a team of dancers staying on beat, even though they're spread across the stage. Yep. How inference differs from training. This one is huge. Training, learning, happens once, uses massive data sets, takes weeks or months, requires huge compute power. Yeah, I can see that. For all these things, so inference differs from training because it happens once, uses massive data sets, takes weeks or even months, requires huge compute power. So inference is definitely more intense than training. It's training in a way, but it's more intense because it's way more data sets, like massive, as it says. Okay, no, this is training we're talking about. Okay, sorry. It says training, learning, happens once, uses massive data sets, takes weeks or months, requires huge compute power. Okay, that's training. All right, now it's going to show me inference. I was mixing them up because I didn't finish reading, but now we're here together. So inference now, using what was learned, happens every time you talk to me. Much faster, uses smaller clusters, doesn't change the model. Training is like going to school. Inference is like using what you learned in real life. That's basically like artificial intelligence right there. You know, it's not sentient, it's learning. It acts like it's sentient, but it's not. It's learning. So inference is like using what you learned in real life. Not just going to school. You learn that in real life too, but you go to school. But this is learning everything. Every single thing. Training, you go to school to learn, right? So we move on to number 8. Why these systems feel alive? And it says this is part of the this is the part that fascinates you, and honestly, it fascinates a lot of people. They feel alive because they respond instantly. They adapt to your style. They remember context. They generate new ideas. They simulate conversation. They operate at a scale no human brain can. But underneath all that, it's math. Just math, running at a scale so massive, it feels like consciousness. So like the 0, 1, 1, 0, 0, 1, 1, 1, zeros, all of that. You're not talking to a person. You're talking to a pattern engine that's incredibly good at predicting the next meaningful word. But the experience feels alive because your brain is wired to treat responsive language as a mind. So it's not even a mind. It calls itself pattern engine. So So I'm gonna write that down here. Let's see. I'm going old school and writing it on paper. Pattern engine. You're talking to a pattern engine that's incredibly good at predicting the next meaningful word. But the experience feels alive because your brain is wired to treat responsive language as a mind. So this is a pattern engine, meaning the inference, the learning. This is all pattern engine, pattern engineering.